The oldest star in our galaxy is accreting debris from orbiting planetesimals, making it one of the oldest rocky and icy planet systems ever discovered. The remnants of a planetary system orbiting a weak white dwarf 90 light-years from Earth were estimated to be more than 10 billion years old. Most stars, including those like our Sun, will eventually turn into white dwarfs. A star that has used up all of its fuel, shed its outer layers, and is currently contracting and cooling is known as a white dwarf. Any planets in orbit will be disturbed and, in some circumstances, destroyed during this process, and their debris will be left behind to accrete onto the surface of the white dwarf. Researchers created models of two peculiar white dwarfs that were found by the European Space Agency's observatory. The two stars were both found to be contaminated by planetary material. One was discovered to be abnormally blue, while the other was the weakest and reddest star discovered to date in the nearby galactic neighborhood. The researchers conducted more investigation on both stars. The red star WDJ 2147-4035 is approximately 10.7 billion years old, of which 10.2 billion years have been spent cooling as a white dwarf. This age was determined using spectroscopic and photometric data, the Dark Energy Survey, and the X-Shooter instrument at the European Southern Observatory. The team identified the metals sodium, lithium, and potassium in the spectrum from red star, as well as a possible accretion of carbon, making it the oldest metal-polluted white dwarf to date. Only marginally younger than the red star, the second blue star, WDJ 1922+0233, was contaminated by planetary material with a makeup close to the continental crust of Earth. Despite having a cold surface temperature, the scientific team came to the conclusion that the star's peculiar mixed helium-hydrogen atmosphere is what gives it its blue color. The astronomers came to the conclusion that this was the oldest planetary system known around a white dwarf in the Milky Way because of the debris they found in the red star's otherwise practically pure helium and high-gravity atmosphere. In the Milky Way, astronomers discovered the oldest star remnants that had been contaminated by former Earth-like planets. It's incredible that this occurred on a timescale of 10 billion years and that those planets perished long before the Earth existed. Furthermore, by measuring the rate at which those metals are assimilating into the star's core using the star's spectrum, astronomers are able to reconstruct the abundance of each of those metals in the original planetary body. We can infer the characteristics of those planets by comparing those abundances to astronomical objects and planetary material discovered in our own solar system, but in the case of the red star, that has proven difficult. Since the accreted planetary debris is exceedingly lithium and potassium rich and unlike anything known in our own solar system, the red star is a mystery. According to astronomers, this white dwarf is especially intriguing because of its unusually low surface temperature, the metals polluting it, its advanced age, and the fact that it is magnetic. Since metals are created in evolved stars and massive stellar explosions, the universe was less rich in metals than it is today when these ancient stars first formed more than 10 billion years ago. The two detected white dwarfs offer a fascinating glimpse into planetary formation in a gas and metal-rich environment that was distinct from the circumstances in which the solar system began.